Arduinos. I'm gonna talk about what they are, what they can do and the basics of how to set one up to do simple things, like make an LED dimming circuit, control the speed of motors and even make a simple oscilloscope. So what is an Arduino? I'm sure you've heard about these things a million times by now, and if you're confused, you have every right to be, because the word Arduino refers to so many different things. Keep watching and I'll explain all of them. Microcontrollers are integrated circuits that are basically tiny computers. They can run small simple software programs. They're low-powered enough that they can be powered by a battery for days, but they're fast enough to process data much faster than any human being can think. Arduino is a company in Italy that designs and sells circuit boards that make microcontrollers easy to use. They call the circuit boards Arduino, and there are a lot of different types of Arduino. For example, you've got simple Arduino boards like the Arduino Uno, which is cheap and good enough for most projects. You could use an Arduino to control motors, lighting, cameras, or even build a simple robot. And then, you have more fancy Arduino with more powerful processors, which have Wi-Fi, internet and more. The company Arduino open sources all of their hardware designs, which means that you don't just have to buy from them. There are countless third-party companies that make their own variants of the Arduino hardware to science. They can't call the Arduino, but functionally they are the same thing. These things called Arduino shields, which are basically circuit boards that plug into your main Arduino circuit board, and let you do more stuff. For example, Adafruits makes shields that let you control motors and servos without having to design motor control circuitry, and SparkFun have shields that let you turn your Arduino into a simple cell phone or an MP3 player. Okay, so that was a quick overview of Arduino the company and Arduino hardware, but there's more. There's also the Arduino software development environment, and this is what makes Arduino good for beginners. Historically, if you wanted to program microcontrollers, you'd have to type out a lot of binary and memorize a lot of hard-to-remember registers and instructions. Then you'd have to use special programming hardware with custom-made cables to upload your program onto your microcontroller. Arduino the company got rid of all of that. They created software that works on Windows, Mac and Linux X, which makes uploading your code as simple as connecting USB cable and clicking a button. They created a programming language that lets you configure all of the Arduino hardware products in the same way, and although it's not as simple as learning Python, the Arduino software is one of the easiest programming experiences you'll ever have. Okay, so hopefully that clarifies what Arduino means in different contexts now. When people say they used an Arduino for their project, they're probably talking about the Arduino Uno. It's highly unlikely that you'll outgrow one anytime soon, so it's the perfect Arduino hardware for this beginner's tutorial. You can get them from robotic.com cheaply, and if you have the money, I recommend buying one of the many Who Know kits out there, where you get a lot of different pieces of hardware to play with. Okay, so you've got your Arduino Uno. The first thing I want to do is get you familiar with the hardware. You'll often hear Arduino is being called microcontrollers, and that is technically incorrect. The Windows are circuit boards that have microcontroller chips on them, but they also have a lot of other stuff on there too. Let's take a quick tour. This is the microcontroller Arduino. Who Knows use a series of microcontrollers called Atmega. They're made by a company called Atmel. You can buy just the bare chips on their own for about $1, but then you'd have to do a lot of soldering. Connected to the microcontroller is a crystal resonator. This controls how fast the microcontroller is running. I have a separate tutorial on resonators and oscillators which you might find useful. Now, in order to upload the software you create to the main microcontroller, there's actually another microcontroller. This chip is what lets you connect your USB cable to the Arduino board and communicate via USB. It lets you upload your programs onto the main microcontroller. And once you have your program running, this chip is what allows you to send messages back and forth between your computer and your Arduino. And this is extremely important for debugging. One great thing about Arduino is that you can power them purely from your USB cable, but if you don't want your project always attached to a computer, you can just use an external 9-volt DC power source with a barrel jack over here that, has a built-in voltage regulator that'll reduce the voltage to 5 volts. And if you ever want to reboot your Arduino its program, you've got a reset button. If you have time, it's worth studying the Arduino Uno schematic. Don't worry if it looks complicated, you don't need to understand most of it. I'm just trying to get you to understand what they are doing. Designers they took an off-the-shelf microcontroller that requires a lot of extra parts to get working. And they put all of those things together in an easy-to-use way, and if you choose to learn more about electronics you can create circuit boards like this too. Okay, so that's what's under the hood. Next let's talk about the pin connectors. Over here, you have the power pins. If you want you can connect wires here to other circuitry with 5 volts or 3.3 volts. Just make sure that whatever you power doesn't draw more than a few million amps. A few LEDs is okay, but a large motor would be on Arduino. TX and RX is for sending and receiving serial data. You could use this port to send and receive data from a GPS module, Bluetooth modules, Wi-Fi modules and more. Pins 2 to 13 are for digital inputs and outputs. Normally when people think of binary, you think of just spitting out zeros and ones, but with most microcontroller pins you can actually activate a third state and use them as a digital input. So you can use this pin as an output, where it spits out 5 volts for a digital 1 or 0 volts for digital 0, or you can internally configure the Arduino to expect a voltage on the pin, and that voltage could be interpreted as a 1 or a 0. It's a system called tri-state logic and it's worth reading up on, but Arduino makes it really easy to change between inputs and outputs in software. Here we have 6 analog input pins, and these are used to measure continuous voltages anywhere from 0 volts to 5 volts. I'll talk more about this later in the video. Finally, some of the pins have a tilde in front of them, and this means that you can use them to output pulse width modulated square waves, which I'll also show later in the video. Okay, enough about the hardware. Most of the work you do with your Arduino will actually be in the software. So start out by downloading the Arduino software from arduino.cc. During the installation you can expect a lot of products like this to show up where you're asked. If you want to install various drivers, just say yes to everything. Once you're done, connect the Arduino to your computer with a USB cable. Next, start up the Arduino development environment. The first thing that you want to do is make sure that the software tries to connect to the right type of Arduino. Go to Tools, Boards, and we're going to be using an Arduino Uno. Next, we have to make sure that the Arduino environment can actually connect and communicate with your Arduino. Go to Tools, Ports, and select the COM or serial port, where your Arduino was connected. If there isn't an Arduino listed here, you may have a problem with your drivers, or you can try plugging your Arduino into a different USB port. The Arduino software has a ton of fantastic easy-to-follow demo programs, and studying these is the best place to start learning how to code. Arduino calls them sketches, which is just a fancy name for a program that you upload your Arduino. Let's start with an example where we measure voltages that are being fed into the Arduino. Go to File, Examples, Basics, Analog, Read Serial. All the Arduino examples contain instructions on how to set up the hardware. This one is telling us attach the center pin of a potentiometer pin as 0 and the outside pins to plus 5 volts and ground. Okay, let's do that. A 1K or a 10K potentiometer will work great for this. We're gonna be using it as a voltage divider to create a voltage anywhere from 0 to 5 volts. Make sure you watch my voltage divider tutorial if you don't understand how that works. Every Arduino program will have 2 main areas: the setup and the loop. The setup area is where you configure your Arduino to do certain things for the duration of your program. It could be information on which pins are inputs and which are output. But in this case we're telling it to send serial data to our computer at 9600 bits per second, which is a pretty standard data rate for these situations. The loop is the area of code that repeats over and over again for as long as the Arduino has power to it. This line will measure the voltage on pin 0 and store the value of it in a temporary place in memory, that we're calling sensor value. Sensor value is an integer, meaning it's a whole number. Once we've copied the analog voltage reading to sensor value, the command serial.println will transmit that value. We know through the USB cable to our computer and we can view it. Click Upload, it'll compile a sketch and upload it to your Arduino. Now hit the reset button. Now go to Tools Serial Monitor. You should see a bunch of numbers flying by. As you vary the potentiometer from 0 to 5 volts, you should see a number on screen from 0 to 1023. This is because internally the Arduino represents the analog voltages it measures with the 10-bit number, which can be from 0 to 1023. The number scales linearly with the voltage, so 2.5 volts would be halfway down at 512. You can use these formulas to convert from analog tape values to real-world voltages and vice versa. Now close the serial monitor and go to Tools Serial Plotter. Now you can get a graph of the voltage your potentiometer is creating over time. It's basically a very simple low-bandwidth oscilloscope. Let's try another experiment where we build a simple LED dimmer. Go to File, Examples, Analog In Out Serial. The instructions for the potentiometer are the same as before. It also says to connect an LED from digital pin 9 to ground. Note that it is implied that you will put a resistor in series with the LED the pins on. Arduino can't supply much current any more than about 20 millions and you risk permanently destroying that 10. I have detailed tutorials on LEDs and resistor values, but for now let's just use a 1K resistor attached to ground. The other side goes to the cathode of an LED and the LED's anode goes. The serial printing stuff is similar to what we had before, and at the end of each loop the delay function will make the Arduino pause execution of all code for a specific number of milliseconds. Once again we click Upload, hit Reset on the Arduino, and now we have a system that can control the brightness of an LED with a potentiometer. Now you're probably thinking, so what, you can do that without Arduino? Let's probe the output of pin 9 with an oscilloscope to see what's really happening here. We've got a pulse with modulated square wave. We can control it with the potentiometer. Thank you for watching, and if you found this video useful, please check out my sponsor website www.robotic.com. Also share and subscribe. Thank you.